Now we are going to study the chapter matrices. What is matrix? First of all, chapter matrices is about matrix. Okay, so what is a matrix? Matrix is just a representation of numbers and in a rectangular form which has numbers in rows and columns. If you see over here, this is a matrix with numbers A, B, C and D. Okay, so A, B, C and D are the four numbers in this matrix. Okay, so now we have this as rows and columns. Matrix is always a group of rows and columns written together. Okay, so how do we write what are the rows and what are the columns in this? First of all, the rows are all the horizontal lines in a matrix. Okay, rows are the horizontal lines in a matrix. Columns are the vertical lines. Okay, so now over here, this example, this is just one example of matrix. Matrices are of a lot of kinds. This is just one kind of a matrix that is of the order 2 by 2. So how do we know the order of the matrix? Order of the matrix is always and always equal to, first of all, we write the number of rows into the number of columns. So in this example, what do we have? We have how many rows? How many horizontal lines? 1 and 2. In one we have A and B, in the other we have C and D. And how many vertical lines? In one we have A and C, and other we have A, B and D. So the order is rows into number of rows into number of columns. So the order is written over here like this. This is number of rows into number of columns, right? Okay, so this is number of rows, this is number of columns, that is the order. So what is the order? Number of rows into number of columns. This is how it is written. We don't have to 2 and 2 multiply and make it 4. No, this is how it's written, 2 into by 4. 2 by 2 matrix is written as 2 into 2, right? So this is called a 2 by 2 matrix, right? Because it has 2 rows and 2 columns. Okay, and this is how a matrix is mentioned. The matrix is always mentioned by a capital letter, and then we have Aij. What do we mean by Ij? I here is the number of row and J here is the number of column. So element Aij, if I write element A21, that means that element is on the row 2 and column 1. So if in this I have to say that what is element A21. So what is element A21 in this? A21 means second row and first column. So which one is the second row? This is the first row, this is the second row. So this is the second row, and which is the first column? This is the first column. So this is A21. Same way as what is A22? Second row, second column. Second row, second column. So this is A22. A11, first row, first column. A12, first row, second column. Right? So this is how all the elements are written. And m into n, m is the number of rows, n is the number of columns. Right? Aij, m into n. This is the representation of a matrix. Right? So what I'm going to do now is I'm going to take a few examples of matrices. Right? So first of all, we have, let's say, A is equal to 2, 3, 4, 8. Let's say this is A is the matrix 2, 3, 4, 8. Okay, let's just write it out like 6, 9. Okay, so now A is a matrix 2, 3, 6, 8, 9. So first of all, 2, 3, 6, 4, 8, 9. This is the matrix. Okay, so now we have, what do we have? What is the row? Well, how many rows do we have? First of all, horizontal lines. One horizontal line, second horizontal line. So 2. How many columns do we have? 1, 2, 3. 3 columns. What is the order? Number of rows by number of columns. So this is 2 by 3 matrix. Am I right? Right? Now if I say, tell me what is A23. What is A23? In this column, what is A23? A23 is the element that is on the second row and third column. A23, that is second row and third column, that is equal to 9, right? Now tell me what is A22, second row, second column. Second row, second column, 8. A22 is equal to 8. What is A21? Second row, first column. Second row, first column. That is equal to 4. What is A12? First row, second column, right? A12, first row, second column. First row, second column, 3. A13, first row, third column. First row, third column, 6. Right? So these are how we come to know about the elements of a matrix. Right? Now let me take another example of matrix. Right? I'm just erasing this. So another example is this. Now what is the order of this matrix? Number of rows into number of columns. How many rows are there? There are 3 rows. And how many columns? 2 columns. So this is A3, 2. And again A2, what is A21? That is second row, first column, right? A21, second row, that is 6, 4, and the first column is 6. So this is A21, right? And same ways you can know the other elements too. So now we have equality of matrices or equal matrices. What are equal matrices? Now for any matrix to be equal, you have 2 conditions. First condition is that the order of both the matrices should be same. Okay, first of all, the order of both the matrices should be same. And then second, we have, if the order is same, after that all the corresponding elements should be same. Do you understand? We have, first of all, the order should be same, and second, all the corresponding elements should be same. Now let me take an example. We have one matrix as 2, 4, 6, 9, right? 2, 4, 6, 9. What is the order of this matrix? It is 2 by 2. And this matrix is equal to this matrix, 2, 4, 6, 9, right? Order is same and all the corresponding elements are same, right? Now, if we say that 2, 4, 6, 9 and the other matrix which we have over here is equal to 2, 4, 6, 9, 8, 3. Are these both matrices equal? No, they are not. Why? Because order is not same. The corresponding elements like 1, 1 is equal to 1, 1, 1, 2 is equal to 1, 2, 2, 1 is equal to 2, 1, 2, 2 is equal to 2, 2, but there is no 3, 1 in this, and there is a 3, 1 in this. So this matrix is not equal to this matrix, not equal, right? So now another example I will take. Now suppose that we have a matrix 2, 4, 3, 6, 9, 8, and we have another matrix that is 2, 3, 4, 6, 8, 9. Okay. Now tell me, is this matrix equal to this matrix? No. The order is same, but this element is equal to this element is equal to this element, this 4 is not equal to 3. Yes, the elements, if we rearrange them, they are same, but right now they are not same, right? This 4 is not equal to the 3. So the corresponding elements should be same. So these two matrices are not equal again. Do you understand? Now if we say, now let me tell you, if we say that this matrix 2 by 2, 3 is equal to this matrix x, y. What does this mean? This means that the value of x is equal to 2 and y is equal to 3. This means x is equal to 2 and y is equal to 3. That is it. This is the equality of matrices. So till now what have we studied? First of all, what is a matrix? Rows, columns, order. Then we know how to write the elements. Then we know how to find the order, how to write the elements, and we know the equality of matrices, right? Now let's move on to some special types of matrices, okay? So now what are the special types of matrices? First is row matrix. Now if the name tells you all about it, what is a row matrix? A row matrix is that matrix in which there is just one column and there can be a lot of rows. There can be n number of rows, but there can only be one column. Okay, so now what were rows? Horizontal lines. There can be n number of horizontal lines. Sorry, there can only be one row. I just totally screwed it. I spoke totally wrong. Row matrix is that matrix in which there can only be one row and n number of columns. So a row matrix is horizontal. Rows are horizontal lines, right? Just forget about what I said earlier. Row matrix is a matrix which has only one row. Okay, I'm really sorry. Row matrix is that matrix which has only one row. That means that any matrix, what is a row? Row is a horizontal line. So an example of this matrix is 2. We don't use commas in matrix. Remember that, okay? We have 2, 3, 4, 6. This is a row matrix. Or we can say 2, 3 row matrix. Or we can say 2, 6 row matrix. All row matrix will look like this. Row matrices just have one row. Same way, column matrices only have one column. Okay. So how do we find that? How do we write that? This or this or this. All these are column matrices. Okay, clear? What is a square matrix now? Square matrix is that matrix which is not a rectangle but a square. That means the number of rows is equal to the number of columns. That is easy. The number of rows should be equal to the number of columns. So this 2 by 2 matrix, square matrix, or square matrix, that is 3 by 3 matrix. Same way 4 by 4, 5 by 5. All these are square matrices. Okay. Next, what do we have is 0 or a null matrix. 0 or null matrix is that matrix in which all the elements are 0. The order does not matter. It can be a row matrix, it can be a column matrix, it can be a square matrix or any other kind of matrix, but all the elements should be 0. So we have the examples 0, 0, 0, or we have 0, 0, or we have 0, 0, 0, 0, or we have 0, 0, 0, 0, 0, 0. All these are 0 matrices or null matrices. Okay. The last type we have identity matrix. Now first of all, what you need to remember is that all the identity matrices are square matrices. So identity matrix can only occur in square matrix. Okay. Now I'll just make a square matrix. All of its elements are 0 except for the diagonal elements. Okay. And all the diagonal elements are 1. What are diagonal elements? A11, A1, A22, A33. All these elements are 1. Rest all elements are 0 and it should be a square matrix. Remember that. I'll give you examples. Now identity matrix of order 2 by 2. What does it look like? It looks like 1, 0, 0, 1. So this is 1, 1. This is 2, 2. Those are 1. Rest everything is 0. Now of the order 3 by 3. That is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. All these are identity matrices. Now we know what special kind of matrices are and we know what matrices are. Now we are going to cover a few questions based on matrices.